Okay. So at the beginning of this course in class, we started with graphs. And the first thing that comes when we do analysis is we want to look at the graph, or we want to look at the data graphically, visually, so that we can have an idea how it looks like. So we have seen like histograms, we have seen like bar graphs, bar chart, or pie chart, and others, box plot, and so on and so forth. And different graph gives us different information. For example, histogram can give us an idea about the distribution, whether it is unimodal, multimodal, symmetric, and so on and so forth. Box plot, we can use it still. It can tell us something about the symmetry of the distribution. It can tell us about if we have, or if there exists an outlier or some unusual data or observation, and so on. And here we have another one, which we call the scatter plot. The scatter plot. And this is used when we try to look at the relationship between two quantitative data. So here our variables are quantitative, and we have, or we need at least two quantitative variables. So here we use the, why is my handwriting? So we use this X. Okay. Here we have X and Y. So these are the two variables. So we need two variables in order to have, or in order to create a scatter plot. The same with correlation, and the same with simple linear regression. So we need two quantitative variables. We don't want now qualitative or categorical variables. Both of them, they have to be quantitative. A simple example would be weight and height, or maybe this, let me make this one height and weight. Okay, so if you want to look at the, or to see the relationship between weight and height of a class, or in our class, for example, if we have 30 students, so you just collect the data of their height and their weight, and then you can just look at the graph. How does it look like? For example, as the height increases, does the weight increase? Or as the height decreases, does the weight decrease? Is there direct relationship between those, or inverse relationship between those? Or if it is, it like the, can it tell us something? Can we get some information out of this? So this is what we call the scatter plots. Okay. So in order to have, or in order to construct a scatter plot, what we need is two quantitative variables. And the scatter plot is used to detect patterns, trends, and relationships, okay? And extraordinary values, which means, again, outliers, okay? Again, using the scatter plot, we can see if there is an outlier or not. But this outlier, this extraordinary value, using scatter plot, there is no measurement. If you remember using box plot, we had the, we would construct so we had this, and if it falls, this is Q3 plus 1.5 the IQR. So if it falls outside this region, then we would call an outlier. So in that case, in this case, we have a measurement. At least we have some boundary, whether to call it an outlier or not. But here we don't have a boundary. The thing is, you just use your imagination. You just look at the data, and if it's too far, it's up to you to decide whether to call this one outlier or not. Okay. So these are something that we can get out of this scatter plot. But now, what is scatter plot, or how do I create a scatter plot. So I will use the help of StatCrunch here. I'm going to use StatCrunch, and I have an example here, data, and this data is on the left side, or the first column. We have number of salespeople working, and here we have sales in thousands. So if when there were 2 people, they sold, total sales was 10,000, and 3 people 11,000, and so on and so forth. Okay. Now the question is, how do we put this one into scatter plot? Now, when you have data like this one, the first thing is which one should be X and which one should be Y. Now, there is a natural dependency. Well, which one comes first, at least? So, for example, do we think this one comes after this one, or this one comes after this one? I believe this has to be first, right? Because as the number of people or the number of sales people increases, then probably this one increase or decrease, because this one comes after this one. So this would be my X variable, and this would be my Y variable, which basically means we will see the X is, we call it explanatory variable and or independent variable. And the Y is response variable or dependent variable. Okay, both terms, they are, we can use both of them, either this group or this one, dependent, independent, and so on. Therefore, once you figure out what your X is and what your Y is, then because we're gonna construct an XY plane, so now we know what comes on the X-axis and what is on the Y-axis. So on the Y-axis, I will have the Y variable, and on the X-axis, I will have the X variable. And then, before we go to StatCrunch, let's just start. So we have, when the number of sales people is are 2, this is 10 or 10,000. So what I have here on the X variable, I have 10. On the Y variable, let's say 10 is somewhere in here. So you put a dot here, and you do the same thing for the rest, and then probably you will have something like this. Okay, and this is what we call the scatter plot. Just, you don't use a line for it, just the dots. Okay, now you can look at this one, and you see if there is a pattern or not. I have this data on StatCrunch. You too, you have it. This is just from the data on StatCrunch. So if you want, you can just go to the data on StatCrunch and have a look at it. These are the data. So it is in chapter 6, scatter plots, association, and correlation. And here I have the data. So I wanted to create a scatter plot out of this, and I will go to graphs. And what is scatter plot? It's here, scatter plot. Okay. Then here it's asking us what is our X variable and what is our Y variable. So the X variable is the number of cells, and the Y variable is cells. So here, by default, you don't have to choose this one because already it's selected. So, but this is by default points, and obviously it has to be point. And here we have, let me copy this one. I'm gonna put it here. Okay. So here I have the scatter plot for this data. And as you can see, these are the coordinates of each of this. So the first one is probably this one. X value is 2, Y value is 10. And the second one, X is 3, Y is 11, and so on and so forth. So we have this scatter plot now. Now, based on this, you can see as the number of sales people, as you increase or as you hire more and more people, the number of sales in thousands is increasing. So probably the manager probably would be encouraged just by looking at this analysis, probably would be encouraged to hire more people, right? So this is what information we can get from scatter plot. Now, if you look at this one, if you look at this value, you may say it's far from it, but this is not. When we have outliers, they have to be somewhere on this side, not on this side, because this is on the line. It's going straight, like on the line. So even if you have far from the data, probably it could be kind of outlier, but it's as long as it's on this straight line, then it's fine. But if you have something outside this one, then that would be somehow kind of an outlier. Okay, because we will see the problem with this kind of points when we reach to correlation and linear regression. Okay, now from this scatter plot, what do we see? So here we have, one is the direction of the association. As you can see, there is association between the two. So you can see it's going upwards, or as we go from left to right, it's increasing. So I can say the direction about that. We can say something about the direction. And when it goes to this direction, if this increases as we go from left to right, it is positive relationship or positive association. Okay, but if it is let me put this. If we have, for example, something like this, as you can see now, the pattern is going downwards. So this here we have negative association. Okay, and sometimes we may have no association at all. We may have, let's say, for example, you don't see any pattern, just the points are all over this, just kind of circle. Okay, so you don't see any pattern. So in this case, you would say no association at all, or no relationship. Okay, so broadly we can say we can have negative association, we can have positive, or we can have no association. So in this case we have a positive because it's increasing. And the second information that we can get from here is the form of the association. can we approximate this one using a straight line? Is it a linear association? That's what we mean by form. Or is it nonlinear? Because it could be, we can have a curved one, we can have a broken line kind of this, or we can have a straight line. So what type of association do we have here? So don't try to connect each and every point like this one. If you do so, then you will have, well, you cannot have a straight line, obviously. But just look at this one overall. Can I draw a straight line here, which is very close, or not very, but which is close to all the, on average, to all the points? It doesn't have to touch each and every point, okay? So in terms of the form, we have a linear association.
Get shit done on your hands, okay? That fucking hurt. They poked me 4 times.
Oh, I'm sorry. I didn't mute my mic.
Okay.
Very sorry for that disruption.
That's okay. Just turn it off now. It's fine. All right. So here, what do we have? Now I can have a linear one. This is, it could be a straight line. It could be, it could be an increasing straight line. It could be an decreasing straight line, and so on. So we can have a linear form. We can have a curved one or gently curved. I will just to differentiate it. Just gently curved. And this is kind of parabola, not parabola, kind of curved one. Or it could be something like this. Okay. If the pattern looks something like this. Or the third possibility is if we can have ups and downs. And downs. Okay. If we have something like this. Okay. Now, by just looking at this one, I can figure out what this pattern or what the form of the association is. And the fourth one, the third one, is the strength. The strength of the relationship. So it could be, we can say strong, we can say moderate, we can say okay, let me just or non-linear relationship, or you can even include, if you want to, we can say weak relationship or weak association. Okay, so these are the possibilities, or the three information that we can get, and the fourth one obviously is the outlier. We can figure out if there is an outlier or not. Okay, we can have an idea actually whether it's an outlier or not, but we cannot be that sure if it's an outlier. Okay, so this is just the overview of the information that we can get from a scatter plot. So here I can draw a straight line, okay, that approximates the well, approximately this line has to be very close to all the points, okay, but it doesn't have to touch to all of them. But if I have, for example, if I have a scatter plot something like this, then this is curved. I cannot use a straight line for this one. A straight line will be very bad for this. Is it going to be like this one? like this one or this one. I don't know. I don't know which one is the best one. Okay, so the best way to fit this one or to draw a line is a curved line. In that case, we will have this option, this curve option. Okay, but this one, we can use a straight line to approximate it. So we have a linear relationship here. You don't have to worry about those outside. We don't want them to be very far, but still they are okay. All right. Now the question is, can I quantify this relationship? Because here we say we can tell about the strength of the relationship based on the scatter plot. So here, as you can see, since all the points are close to the line, so I can say, let me put the actual line here. I will include the line. What is it? Oops, that's not the line. Okay, I don't know if I have the option to fit the line. Okay. Yeah, here it is. This is the line. Now let me copy this one and okay. So here we have this line or this scatter plot. And as you can see, this is the line. This is the actual line. Actually, that's not mine. So here we can say it's not that far. The points are not far from the line. So I can say there is a strong relationship between these two variables, okay, the cells and the number of people working. There is a strong relationship. But the thing is, how strong is it? Can I put this one numerically? And that's the question now. And to answer that question, we go to correlation. Okay, so the scatter plot is just a visual information or a visualization of the data. And then to quantify the relationship, to put it in numerically, we go to correlation. Now, well, this is the data. Now here we have correlation. Well, correlation measures the strength of linear association. Remember this linear association between two quantitative variables. So this correlation, this is, we call it the simple or Pearson correlation coefficient. This correlation, it measures the linear association. I don't care if it's curved. No, I cannot. We can't. Of course we can, but it will be very weak. So we only care about the linearity of the association. Now, in order to find the correlation, I need this summaries. And okay, before I go to this, this is the example. Where did I put that one? I don't know. Okay. So correlation is given by the correlation coefficient. ignore this values for now, correlation coefficient. This is the quantifying the association. So this is given by R equals to, in short, Sxy. Both of them, they are subscript over Sx and Sy. Do you remember? If you remember this S sub x and S sub y, S sub x is the standard deviation of the x variable. So here we have the x variable. So we can calculate the mean of this independently, independent of the other variable. I can calculate the mean, which is this one. I can calculate the standard deviation, and I got this one. So those two values are from this variable. So here we have a summation of x minus x bar squared over n minus 1. And S sub y is the same, but now using the y variable, y minus y bar squared over n minus 1. So those are something that we are familiar with. Standard deviation and the standard deviation of x values and y values. How about this one now? Sxy. And this is summation of x minus x bar, y minus y bar, okay, over n minus 1. And this is what we call the Sxy. So as you can see, if I plug those values in here, it will be very complicated. Imagine putting this one here, this one here, this one here. It will be kind of messy. So the best way is just find them independently. You don't have to. Well, here you have the start point, so you don't have to worry. But in general, just finding them separately is much more easier, and it will reduce the mess of the work. So this is what we call the correlation coefficient. Okay, this is the correlation coefficient given by this formula. Now, what are the possible values of the correlation coefficient? Of R. So this R is always between -1 and +1. Okay, let me put it +1. So it's always between these two values. And if R is negative, which means less than 0, then we have a negative relationship. Okay, if we have negative R, then it tells us there is negative relationship. If R is positive, then we have a positive relationship. Now, how about the strength? I mean, when do we say it's strong? When do we say it's not strong? Well, it's not. Let me put it this way. So if R is, for example, like we have some boundaries, but usually if R is between, let's say, absolute, okay. I'm thinking how to put it. Okay, so if R is close to -1, then there is strong negative relationship. I will put it in short, the relationship. If R is close to +1, then there is strong positive now, positive relationship. And if R is close to 0, then we say there is either we say weak if it is somewhere around 0.1 or something, or no association. Okay. No relationship. Okay. So these are the general idea of interpreting this R value or the correlation coefficient. So remember, if it is close to -1, you have a very strong negative relationship, which means R negative means this one. This is R is negative. If R is positive, then you have this kind of line. R is positive here. Okay. And R is 0, just the same interpretation with slope. If you remember in algebra, we have the slope. So positive slope indicates increasing line, negative slope indicates decreasing line. And if the slope is 0, then you have a horizontal. Okay. And this is similar. If you have 0 value or very close to 0 or around 0, it could be on the negative side or on the positive side, then it tells us that there is no association between those two variables. Okay. Now let's go back to the same example. So first, let's try to calculate manually. Well, not manually. Still, I'm going to use the StatCrunch, but I will just show you the general idea how it works. So here is the x variable. Now, independently, we can find the mean of these values, and I got the mean to be 17.6, and the standard deviation of this x values, s sub x is the standard deviation, is 5.34. And the same for y values. The y bar is 10.4, and I'm sorry, this has to be the other way around. I did something wrong here. This has to be this has to be y, I think, yeah, because this is, and this has to be x. Yeah. Okay. So here are the summary, the means and the standard deviations of each of them. The third one, to find this s sub xy, what we could do is we subtract each x, the mean of x from each value, x minus x bar. So here I got these values. And we do the same thing with y values. If you remember, the sum of these values, it has to be 0, and the sum of these values has to be 0. Okay. And then we multiply these differences, the corresponding differences. So this times this, we got this times this one, and so on and so forth. And once you do all of that, you add them up. Obviously, you will get some negative values. In this case, we have two negative values because this is negative, this is positive, so the product is negative, and we have another one, again negative. but the rest, all of them, they are positive. And here the sum is 261.6. Now, to find SXY, this is the sum. This numerator is this sum. Therefore, to find S sub XY, you just divide this number by n minus 1. Okay? And then that will be your S sub XY. And you divide this S sub XY by the product of S sub X and S sub Y. Then you will get R. Okay? And remember, just like probability, if you get R outside -1 and +1, outside to the left or to the right, then there is something wrong with your calculation. R, this calculation, if you do it correctly, it has to fall within this interval. Okay. Now I will use StatCrunch for the same data. Well, let's see what we can get. S sub XY is 261.6 over n is 10, I guess. 1, 2, 3, 4, 5, 6. Yeah, over 9. And let me use my phone to divide this. So I got 29.067. And then we have SX and SY. Now let's divide R, let's find R. It will be 29.067 divided by 5.34 times 5.64. Yeah, 64 and 34. 64. And if we yeah, 0.34, I got 0.96510.567 and so on. Anyway, you can round this one, 0.97. Okay. Now, what can we say about this? We will come to StatCrunch, but let's look at this value, the R value, and interpret it. So based on this one, if you look at this, what did we say? If it's close to +1, actually, to +1, then we say there is strong positive relationship. And as you can see, this is close to +1. Okay, this is close to +1. So based on this value, I can say there is a strong positive relationship between the number of people, salespeople, and the sales itself. Okay, positive means now as it increases, as we increase the number of people working here, then the number of sales or the amount increases. And from the scatter plot, we had the same conclusion. This was the scatter plot. And as you can see from here, there is a direct relationship between these two variables. Now, how do we find this using StatCrunch? What is it? Okay. Now let me go to StatCrunch and do the calculation. So for the correlation, what is it? There is one here. There are two ways actually. So if you want to calculate only the correlation, then this is the way. Just if you want the number, just the correlation without any other information, then you have this option. You can go summary stats and then correlation. And then you select both of them. Here it doesn't matter. You don't have to worry about the order. Whether you select X first, then Y first, second. It doesn't matter. It's just correlation, so it doesn't change the value. Now, here is the value now. Correlation between number of cells, this is the one variable, and the other variable is equals to 0.9653665. And I think we got very close to that one, 965. Yes. They are different at this digit. Up to here, we got the same value. And that is just rounding error. Yeah, that's fine. All right. And another way is we go here, then what is it? Regression. We go to this regression, simple linear regression. Okay. And then here we select the variables, X variable, and then Y variable. You don't have to worry about this hypothesis, and we are not going to learn this one, so forget this. It will give you the result, but it doesn't matter. Just ignore that one. Okay. So here is the result from this. So this is the correlation coefficient. For now, ignore all the other values now, all the other results. We will come to this in a moment. But what we are looking for is just this one. This is the value. Okay. Therefore, from this analysis or from this summary, from this correlation, we can say there is a strong relationship between those two variables. Now, the next is the simple linear regression. But before that, if you have any question regarding the correlation. If you don't, I will just continue so that we can save some more time. So this simple linear regression is just a model, just like any other model. This is kind of the simplest model that we use in statistics. And obviously, we use models to predict for the future or for some unknown values. Just like what's going on with this COVID-19, they are using models to predict in the future when it's going to phase out, or when it's going to, or what's going to happen in the next few months, or so on and so on and so forth. So we cannot use this model as, of course, but this is just one model. So the linear model attempts to model the relationship between two variables by fitting a linear equation. That's the model now. It's not complex line or just a weird line. It's just a linear equation. So we fit a linear equation or a line of linear equation to the observer data. We try to fit a line, and that line will be used for predicting for future values and so on and so forth. For example, this is what we are calling the line, this one. So we fit this line. Now, for the future, what I will say, what I can say is, so here what we have is the maximum number of people working are 20, and the amount is 26,000. What happens if I make this one 30? If I hire 10 more, what will happen to this one? So I will have a general idea. If I follow this trend, if we follow this trend, and if we increase this number to 30, then this will be some value, and that will be the prediction, okay, which we get from the model. Okay, so the linear regression line has an equation of the form this one. If you remember this from algebra, we would write it this way: y equals to a plus bx, or ax plus b. I guess it's ax plus b, something like this. So they are the same form, but we don't use this a and b here in statistics. So in statistics, the model, we write it is given by y equals to beta naught plus beta x. This is the linear regression model. Okay, this is how we write the equation. This one is the population, or this is the model. But the thing is, we don't know beta naught, we don't know beta os. This is sub 1, beta sub 1, sorry. So we don't know these two values. Okay, this is just the model. Now, in order to estimate this model, I need to estimate these two values, this beta 1 and beta 0 and beta 1. Okay, and once we estimate those values, the estimates of those are, we use this b sub naught and b sub 1. Here they were beta, but here they are b sub naught and b sub 1. And for the x, we put hat. We put hat here, not bar, it's a hat. Y hat equals to b sub naught plus b sub 1 x. The x doesn't have hat. Okay, therefore, this is what we use. And this is the model, or the equation, or the linear equation that we create from our data. Okay, and we will see how to create those values. So basically, this equation is an equation of this line, an equation of this line. So here, beta sub naught is, the sub 1 is the slope. This is the slope. And it tells us how rapidly y hat changes with respect to x. And beta sub naught is the y-intercept. And the value of y hat, well, the y-intercept is the value of y hat when x is 0. And to find those values, b1 is given by r sy over sx. Now remember, again, we are using this r. Once you have the r, then you can calculate those two, the b1. So for example, in our case, r is approximately 0.97 and sy is 5.6, I guess 64, if I'm not mistaken, and this is 5.34, I think. Okay, and following this, if we do the calculation, 0.97 times 5.64 divided by 5.34. I got 1.024, and then beta b sub naught is given by y bar minus b1 x bar. Now already we have b1 here. From here, this is my b1. This is my b1. Okay, so from here I have b1, y bar and x bar, we already have them. Therefore I can calculate this. Y bar is 17 point something, 17.6 and 10.4 minus b1 is 1.024 times 10.4. So what do we get? 17.6 minus 1.024 times 10.4. I got 6.95. Okay. Now, what is my equation now? So to write the equation, these are the only things that we need to calculate. Okay. So once we have this, then my equation or my line will be y hat equals to beta b, not, b sub naught, which is 6.95, 6.95 plus b1 is 1.024x. This is the equation. Okay, and let's see if we get close numbers to this one using StatCrunch. Obviously, there will be some rounding error, but we expect. So if you look at this one, this is the intercept, and obviously there is a big difference. This is 6.1, and I don't know if there's only rounding error or I mess up somewhere, but this is not only 6.95. Wait. Okay. I think I did something wrong. I don't know. But anyway, here we have the, this is the B subnode. The intercept is the B subnode. And here we got 8.1. And the slope is 0.91. Therefore, the equation becomes, here we have the equation, okay? 8.1 plus 0.9 times the number of cells. So the number of cells, that will be our x variable.